Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudewa Sos Ukobela Maths. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 on work, energy, and power. It says a block of mass 2 kg is released from rest at point P and slides down a rough curved slope from a vertical height of 2 meters, as shown in the diagram below. It reaches its lowest position, point Q, at a speed of 5 meters per second. So from rest, 0 meters per second, and reaches point Q at 5 meters per second. So initial velocity, final velocity. Now 5.1 says, is mechanical energy conserved while the wooden block slides down the slope? Give a reason for the answer. Now the keyword lies here, rough. So if it is rough, that means there is kinetic frictional force. And then if there is kinetic frictional force, that means mechanical energy cannot be conserved, because in order for mechanical energy to be conserved, this has to be an isolated system without any frictional forces, right? So 5.1, we say definitely no. Why? Because there is kinetic frictional force. Or you can say the slope is rough. The slope is rough. Obviously, the fact that the slope is rough means that there is frictional force. Okay, then 5.2 says, state the work energy theorem in words. And then I did mention that if you happen to forget this definition, just go there and write the formula W net is equals to change in EK, and then it is much easier to remember here. Now you can easily state it and say this means that the net work done on an object is equal to the object's change in kinetic energy. Injalo. Right. So whenever you forget it, just write the formula there, and then you'll be able to remember the definition. Then 5.3 says, use the work energy theorem to calculate the work done by the kinetic frictional force experienced by the wooden block as it slides from P to Q. Note, they say use the work energy theorem. And then I've also hinted you to that trend in the exam, whereby if they ask you to define a certain theorem, then you are bound to use it in the question below, right? So note that they just made us define the work energy theorem, and then just below we are told to use the work energy theorem, right? So in other cases, if they ask you to define the non-conservative force, definition of non-conservative force, then in a question below, you are much more likely to use that formula for calculation. Now, be careful if they tell you, remember other questions, they say use energy principles. If they say use energy principles, that means you are not restricted to using using one particular formula. You can use the work energy theorem, you can use the work done by non-conservative forces, and if there is no friction, you can still use the formula for conservation of mechanical energy. But once the question says use the work energy theorem, then you have to use the work energy theorem. Any other formula that you use, they might penalize you and not give you marks, because the instruction clearly states use the work energy theorem. Okay, so be careful of that. Make sure that you read all the statements. Then 5.3, we have our W net is equals to change in EK. Now, let me address this question that I've been seeing a lot more in my videos concerning the work energy theorem, the work energy theorem formula, and also the WNC formula. Now, you have seen me most of the time using the WNC, work done by non-conservative forces. And the question that I get mostly is why I don't include the work done by FG parallel when I'm using this formula, right? So, sir, why are you not including the work done by FG parallel? It's because FG parallel is not a non-conservative force. Remember, FG parallel is a component of weight, and weight or gravitational force is not a non-conservative force, but it is rather a what? A conservative force, right? So whenever we get to use the WNC formula, do not substitute the work done by FG parallel because it is not a non-conservative force, right? But then when I use the WNet formula, you do see me substitute in the work done by FG parallel, because when we use WNet, we substitute anything, whether it's non-conservative or conservative. So the WNet is for all the forces that are doing work, whether they're non-conservative forces or conservative forces. But the WNC formula is only restricted to forces that are non-conservative forces. Now, if you want to know which forces are the non-conservative forces, that's your applied force. So the applied force can go into this formula. Your frictional force can go into that formula. And then also lastly, your tension force can go into that formula. Now, the applied force can come in so many ways. Sometimes it can be in the form of an engine, or it can be a motor, or whatever that's propelling that particular object to move, right? So that's all of the forces that can go into the work done by non-conservative force formula, but not the FG parallel. The FG parallel can only be substituted if you're going to be using the WNet formula. I hope I've clarified that. Okay, so let's now use the WNet formula. So if I have to use that, I have to first figure out the forces acting on the 2 kg block as it slides down. So let's say at a particular point here, we have to draw a free body diagram as it slides down. So this will be the normal force, always perpendicular to the surface. And then here, let me resolve two components. I will have my FG perpendicular, and then sliding down, the incline will be my FG parallel, and then opposing the direction of motion will be the kinetic frictional force. Now, we do know that we don't consider the vertical forces or the forces that are perpendicular to the surface because they do not do any work. So this one will give us 0 joules, and then this will also be 0 joules because forces that are perpendicular to the displacement, they do not do any work on the object, meaning the only forces that are doing work on the object is your FG parallel and also your FK. So the WNet here will be represented by what? Work done by FG parallel plus work done by FK. Again, here you don't have to subtract, right? You just have to add them up, even though they're acting in opposite directions. Remember, what speaks to FK acting in the opposite direction will be the fact that the theta will be 180 degrees. And then here, what speaks to this being in the positive direction will be that theta is 0 degrees. Then, okay, we have our change in EK there. So we are to calculate the work done by the kinetic frictional force, right? So we are to calculate this. So let's have our change in EK here. And then let's now start to break this one down. FG parallel, we know it to be from our Newton's second law, mg sine theta, right? So we're just going to say mg sine theta. But then we are looking for the work done by FG parallel. So I have to say delta x and then cos theta, which is coming from the fact that work done is F delta x cos theta. So that particular force multiplied by delta x cos theta. Then plus work done by Fk. Now we can break down the change in Ek. That's half m Vf squared minus Vi squared. Right. Now the problem is the theta that I'm supposed to substitute here for sine theta, I know it to be the theta of the incline. But then looking at the incline that I've been given here, there is no angle theta. Oh my God, what am I supposed to do now? I'm panicking. No, we just relax. right? Because now we do know trigonometry to say that if we have an angle theta here, we know this to be the height, and then we know this to be the delta x. Now we must find a way to manipulate this so that we no longer have to worry about finding theta and also finding our delta x, because we don't have the displacement, and again we don't have the angle of the incline. But then what we do have is the height. Now we do know from our trigonometry that we can express this as sine theta is equals to opposite, which is h, over the hypotenuse, which is delta x. Now let me make h the subject of the formula. This will be h is equals to sine theta times delta x. Now this is a very important manipulation. Please save it. If you haven't seen anything like this, please save it in your book so that you know that such a manipulation exists, and then it will be able to help you in terms of other questions that you might tackle, because this is more common in your exams, especially for the prelim and the final exam. Then now that means I can replace this. Now that I've found that expression, I can replace the sine theta delta x here by h, right? Because I've concluded that h is equals to sine theta times delta x. So now this will be what? Mg times the height and then cos theta. Now the theta that I have here is not the same theta as this one. This theta is the theta of the displacement and the force, right? So this is the one that can either be 0 degrees or 180 degrees. Then plus work done by Fk. I'm looking for this one, so I cannot break it down. Then this is half m Vf squared minus Vi squared. At this point, let me start to substitute in my values. So what is my mass? 2, and then 9.8. My height, again, is 2 meters. And then cos, the theta here is supposed to be what? 0 degrees, because Fg parallel is in the direction of the displacement. So 0 degrees plus work done by Fk is equals to half the mass 2. Final velocity, we did mention, 5 meters per second, and then that's 5 square. Initial velocity, it was released from rest, so it's 0, and then square, right? So at this point, you just simply need to punch all of this into your calculator. So let's check. If we punch that into our calculator, we have 2 times 9.8 times 2 cos 0, and then which will give us 39.2. So we have 39.2 here, plus work done by Fk. And then when we punch this side here, this is half of 2 is just 1, and then 5 square is 25. So we're going to have 25 here. And then work done by Fk will be equals to 25 minus 39.2. And then simply punch that into your calculator. It's supposed to give you a negative 14.2, right? So in 2 decimal places, that's just 20, and then joules. Now we can see the work done by Fk being a negative because of the theta is equals to 180 degrees there. So, okay, just like that, we have found our solution for work done by Fk. Right, so that's all the trouble that you had to go through in order to find that. So this question was all for a total of 10 marks. That's how you were supposed to go about it. So you know what to do. If you have enjoyed the lesson and then you found it helpful, please press the thumbs up button. But also don't forget to share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.